Hello friends, myself Subhash Nagarse from Sri Digambar Jain Gurukul High School, Solapur. I said welcome to all of you in this session of 9th Mathematics Part 2, that is the geometry. The topic is circle. Here we will consider the part first. Friends, circle part first. You are already familiar with the circle and terms related to circle in the previous standards. Today we will review few properties of this circle and terms related to it. So first we see circle and some related terms with the circle. So friends, and some practice set 6.1. Let us start with the circle. Let us recall. That is, in the adjoining figure, observe the circle with center P. With reference to the figure, complete the following table. So here circle is given with center P and some other terms are given. We have to recall them. The first chord, name of the chord. Here BC is the chord. It is shown here, chord BC is there. Also CD is the chord, but it is the biggest one. Segment PA. What is PA? PA is the radius. You will write radius. But friends, PC and PD are also radius. What is the diameter? This segment CD is the diameter. What is the radius here? PA is the radius, PC is the radius, PD is the radius. Any segment you write, segment PA, segment PC or segment PD. What is the center? P is the center. Point P is the center. What is the central angle? You can write the central angle, angle APC. Angle APC or angle APD. You may consider the central angle. Angle CPA. What is this angle CPA? The central angle only. So this is things we must know from as a base for studying the content of this topic. So we have to learn that circle. Let us describe this circle in terms of the set points. In the mathematics part first, you learned the topic set. By considering that point of view, we will define this set as the set of points in a plane which are equidistant from a fixed point in the plane is nothing but a circle. Means it is a set of points in a plane which are equidistant from a fixed point in the plane is called as circle. Some terms related to the circle are: the fixed point is nothing but a center of the circle. The segment joining the center of the circle and a point on the circle is nothing but a radius of the circle. The distance of point on the circle from the center of the circle is also called the radius of the circle. The segment joining any two points of the circle is called chord of the circle. A chord passing through the center of the circle is called diameter of the circle, or a diameter is nothing but a longest chord of the circle. These things we have been already saw. Let us recall. Now, what are circles in a plane? Congruent circles. These are called as congruent circles because the radii of these two circles are same. Concentric circles. The same circle having the same center but the radius are different are called as the concentric circles. Here circles representing in a point. See how the different centers, different radii, only one common point is there. Here two centers are there, only one point is common between these. These are called as intersecting circles. These are called as externally intersecting. Here these are internally intersecting because here the two circles have only one common point. Now intersecting circles. These two circles, different centers are there, different radius are there, and two common points you are getting here and here. Here only one, in intersecting only one point, here intersecting in 2 points. These are called as touching circles also. These are externally touching circles. This is the internally touching circle. So this is what we find the circles in a plane. Now let's see a theorem. Very important properties regarding this chord. A perpendicular drawn from the center of a circle on its chord bisects the chord. O is the center of the circle, AB is the chord. Here OP is the perpendicular to chord. So what will happen? It is going to divide the chord into two equal parts, that is AP and BP. these two parts are congruent. So what is given from here? Any property, any theorem when we are going to prove, these steps we have to follow. That is, what are the given things, what we have to prove, is there necessary to carry any construction for the proof. If it is necessary, then do the construction. Otherwise, from the given information you can prove the property. So to prove, after that, proof. So from this statement, what are the given? Segment AB is a chord of a circle with center O and OP is perpendicular to AB. What we have to prove? That two parts form AP is equal to OP is congruent. So draw segment OA and segment OB. Here construction in triangle OPA with a brown color, now OPB with a blue color. These two triangles we have to show congruent. So angle OPA is congruent to OPB, each 90, since OP is perpendicular to chord AB, and OP is equal to OP, that is the common side OP in these two triangles, and hypotenuse OA and hypotenuse OB both are radius of the same circle which are congruent. Therefore we can say that triangle OP and triangle OPB are congruent by hypotenuse side test, or a right hypotenuse side test, RHS test you can write. So from this we will get AP is equal to BP, corresponding side of congruent triangle, that which we have to be shown here. This is what theorem 1. The converse of this theorem we will see. Here perpendicular drawn, two equal parts are forming. If midpoint of this and center of the circle join, then this OP is perpendicular to AB we have to prove. So this is the second theorem. The segment joining the center of the circle and the midpoint of its chord is perpendicular to the chord. Here midpoint of the chord, P is the midpoint of the chord they have given. You can see two equal parts, congruent parts, and O is the center. This OP is perpendicular to AB we have to prove. What is the given? Segment AB is a chord of a circle with center O, and P is the midpoint of the chord AB of the circle. That means AP is equal to BP here. What do you have to prove? OP is perpendicular to AB. Now again we have to draw OA and OB, or join OA and OB. There is a formation of two triangles angle, triangle OP and triangle OPB, one shown with pink color, another with blue color. So these two triangles we will consider. In these two triangles, what you will get? OA is equal to OB, means radius of the same circle. OP is equal to OP, this is the common side, and AP is equal to BP, that is given already. So these are the three requirements. Means in order to show any two triangles to be congruent, minimum three conditions we have to satisfy. So the remaining conditions will be naturally satisfied automatically. So three conditions we satisfied: OA is equal to OB, OP is equal to OP, and AP is equal to BP. These are the three conditions. So now we will see these three are sides only. So triangle AOP and triangle BOP, this pink color and blue color, both will be congruent by yes test, means side test. So we'll consider the corresponding angles. Angle OPA congruent with angle OPB. But angle OP and OPB are the linear pair forming. So addition of these two angles is 180. But in the previous step, in statement 1, what we wrote? OP and OPB are congruent. So OPA can be replaced with OPB. OPB plus OPB is equal to 180. So twice of OPB is 180. So OPB is 90. As this OPB angle is 90, so what we can write? Chord OP is perpendicular to AB. So these are the two theorems. By using these two theorems, we will consider the problems. That is practice set 6.1. First problem: distance of a chord from the center of the circle is 8 cm. Distance of the chord, this is AB's chord, this is 8 cm. Length of the chord AB is 12. Find the diameter of the circle. Friends, here in a circle with center O, OA is the radius and AB is the chord. OP is perpendicular to AB, APB is between this, where AB is 12 and OP is 8. So we have to find out the diameter of the circle. We know that perpendicular drawn from the center bisect the chord. So AP will be now here. This triangle shown with yellow color, CAP. AP is half of AB. So perpendicular drawn from the center of the circle to the chord bisect it. This property we are using. So AP is half into 12, that is 6 meter. So here AP is 6 and this OP given as 8. We'll use these two values and apply Pythagoras theorem for this yellow colored triangle, which is triangle OPA. Triangle OPA, this OPA is 90. So OA square is equal to OP square plus AP square. OA is the hypotenuse, side opposite to the 90. OA square is equal to OP square plus AP square. Now we'll put the values. Therefore OA square is equal to 8 square plus 6 square. OA square is equal to 64 plus 36, that is 100. OA square is equal to 100 means taking square root on both sides. OA is under root 100, that is OA is 10. But what is the radius is 10 centimeter, that we are getting OA as the radius. But what is diameter? Twice of the radius. 2 into 10, that is 20 centimeter. So that diameter of the circle is now 20 centimeter. We'll see the problem number 2. Diameter of a circle is 26 centimeter and length of a chord of the circle is 24 centimeter. Find the distance of the chord from the center. So friends, here in the adjoining figure you could see O is the center of the circle and PO is the radius and PQ is the chord. Segment OR is perpendicular to this chord PQ, PRQ. PQ is here given 24, diameter D as a 26 meter. So friends, from diameter we will have to first calculate the radius. So radius is equal to diameter upon 2, 26 upon 2, 13 centimeter. What is PR now? PR is nothing but a half of PQ, since perpendicular drawn from center bisect the chord. So PR is half into 24, 12 centimeter. PR is 12 and this OP is 13. So triangle ORP, which is shown with green color. So what you will get in triangle ORP? Angle R is 90, therefore OP square is equal to OR square plus PR square by using Pythagoras theorem. OP's value is 13 square plus OR square plus PR is 12 square. 13 square is 169 is equal to OR square plus 12 square is 144. So OR square is 169 minus 144, that is 25. Taking square root on both sides, OR is equal to under root 25, that is 5. Square root of 25 is 5. OR is 5 means the distance of the chord from the center of the circle is 5 centimeter. See third problem. Radius of the circle is 34 centimeter and the distance of the chord from the center is 30 centimeter. Find the length of the chord. So friends, here we come to in a circle with center this A, radius of PQ is chord. So it means AM is perpendicular to this PQ, PMQ, AP is 34 and AM is 30. So friends, length of the chord we have to be calculated here. So in triangle AMP, angle M is 90 by using Pythagoras theorem. AP square is equal to AM square plus PM square. Put the values. AP is 34 square is equal to 30 square plus PM square. Therefore PM square is 34 square minus 30 square. So it will be PM square is equal to A plus B, A minus B. This formula we will use. 34 minus 30, 34 plus 30. So PM square is equal to 4 into 64. Therefore PM is equal to under root 4 into 64, that is to 2 into 8. So PM is 16. As PM is equal to 16, we know that PM is half of PQ. Therefore 16 into half into PQ. PQ is equal to 16 into 2, that is 32 centimeter. So you can get the length of the chord of the circle is 32 centimeter. This is what the third problem. Now we'll see the next problem number 4. Radius of the circle with center O is 41 units. Length of a chord PQ is 80 units. Find the distance of the chord from the center of the circle. So here in the figure circle, you could see the center is O, OP is the radius and PQ is the chord. Segment OM is perpendicular to this PQ, chord PQ. PMQ is the between S. This OP is 41 units, PQ is 80 units. Friends, distance of the chord from the center of the circle we have to calculate, that is the OM. We know that perpendicular is drawn, therefore PM is half of PQ. So PM is half into 80, 40 units. Since perpendicular drawn from the center bisecting the chord. This property we are used here. Now in triangle OMP, which is shown with a blue color, we will get OP square is equal to OM square plus PM square by using Pythagoras theorem. OP is 41 square is equal to OM square plus PM is 40 square. So OM square is equal to 41 square minus 40 square. Again we are using the property A square minus B square, A minus B, A plus B. So here 41 minus 40 and 41 plus 40 in the under bracket. So 1 into 81, that is 81. OM square is 81. Taking square root on both sides, OM is 9 units. Means OM is equal to root of 81 is 9 units. So the distance of the chord from the center of the circle is 9 units we will get. Next we will see problem number 5. In this adjoining figure, centers of the two circles is O. Chord AB of the bigger circle intersect the smaller circle at points P and Q. Show that AP is equal to BQ. Here two concentric circles having only common center O. We have to show AP is equal to BQ. Now draw the OM perpendicular to AB. A and B between us you are getting. For a smaller circle inner side, segment OM is perpendicular to PQ. Therefore you can write PM is equal to MQ. Perpendicular drawn from the center of the circle to the chord bisect the chord. For a bigger circle, again OM is perpendicular to AB. Here we will get again AM is equal to MB. The same reason, perpendicular drawn from the center of the circle bisect the chord. Here AP plus PM is equal to MQ plus QB. AM means AP plus PM and MB means MQ plus QB. So AP plus MQ is equal to MQ plus QB since PM is equal to MQ. So we'll get MQ get cancels. What you are getting, AP is equal to BQ. So next we'll see problem number 6. Prove that if a diameter of a circle bisect two chords of the circle, then those two chords are parallel to each other. O is the center of the circle, segment PQ is the diameter. Here diameter PQ bisect the chord ABCD in point M and N respectively. Chord AB is parallel to CD, we have to show. Friends, diameter PQ bisect the chord AB in point M. Therefore, you can write AM is equal to BM. AM is equal to BM. Segment OM is perpendicular to AB. Therefore, we will get OM is perpendicular to chord AB. That is segment joining the center of the circle and the midpoint of the chord is perpendicular to the chord. So, angle OM is 90. Also, diameter PQ bisecting the chord CD in point N. Therefore, CN is equal to DN. Therefore, we can write that this ON is perpendicular to chord CD. Again, the same reason, segment joining the center of the circle and the midpoint of the chord is perpendicular to the chord. So, angle ONC is 90. From 1 and 2, OMA plus ONC is equal to 90 plus 90, which is equal to OMC plus ONC is 180. Means it is a linear one. Therefore, angle OMA and ONC form a linear interior angles on the lines AB and CD when segment MN is their transversal. Therefore, you can write that chord AB is parallel to chord CD. So friends, what we have been discussed today in this video on the following subpoints: circle and parts of the circle. Two theorems we have been saw. A perpendicular drawn from the center of the circle on its chord bisect the chord. The corners of theorem first, that is theorem 2. The segment joining the center of the circle and the midpoint of its chord is perpendicular to the chord. And the various problems from the practice set 6.1. So friends, you try this. Number 1, radius of the circle is 5 cm. The length of a chord of a circle is 8 cm. Find the distance of the chord from the center. Radius of a circle is 20 cm. Distance of the chord from the center of the circle is 12. Find the length of the chord. One activity you carry at the home: draw a circle in your notebook. Draw any chord of the circle. Draw perpendicular to the chord from the center of the circle. Measure the lengths of the two parts of this chord. Activity one more. Every student from the group will have to do this activity. Draw a circle in your notebook. Draw a chord of the circle. Join the midpoints of the chord and the center of the circle. Measure the angles made by the segment with the chord. Discuss about the measures of the angles with your friends. Which property do you observations suggest? So try these problems. Friends, you should not forget the famous words by William Paul Thurston. He says that mathematics is not about numbers, equations, computations or algorithms. It is about understanding. So friends, with these words I would like to say thank you.